Imagine a world where the sun never moves in the sky. On one side, eternal day. On the other, endless night. What would it feel like to live there? Stay with me because this strange planet can totally bend your mind. By the end of this video, you'll understand exactly how day and night work on a tidally locked planet, what the sky would look like, and whether life could even survive there. Let's start with what tidally locked really means. On Earth, we spin like a top, so we get sunrise, noon, sunset. But a tidally locked world keeps the same face to its star, like the moon does to Earth. One side always faces light, the other is stuck in endless darkness. Picture standing on the day side. The star hangs frozen in the same spot of the sky, never rising, never setting. It might be low, high, or right overhead depending on where you live, but it never moves. Creepy, right? Now imagine the night side. No sunrise, no sunset. Just a starless, endless twilight or deep blackness with only faraway stars and maybe a faint glow from the bright side over the horizon. Time would feel totally different. Between these two extremes lies the wildest place, the terminator line where day meets night. Here the star hovers forever on the horizon. It's permanent sunrise or permanent sunset. This thin ring might be the key to life. Let's talk heat. Day side first. With constant light roasting it, the surface could become a blazing desert or even an ocean of molten rock, depending on how close it is to its star. No break, no cool night, just endless baking. On the night side, it's the opposite. No light, almost no warmth. Temperatures could plunge far below anything on Earth. Think frozen plains, thick ice, maybe frozen oceans locked in eternal darkness. Now here's the twist. Air and oceans don't stay still. Hot air from the day side wants to move toward the cold night side, and cold air rushes back. This creates gigantic wind patterns wrapping around the whole planet. Those winds could be unimaginably strong, whipping from day to night, driving huge storms. Imagine standing in the twilight zone with violent winds dragging clouds from a glowing sky toward a star-filled darkness behind you. Oceans would join the chaos. Warm water on the bright side would try to flow toward the frozen dark side, slowly melting some ice, then cooling and sinking. Over time, this could create strange belts of liquid water around the planet. Could anything live there? Maybe. The most promising place is that permanent dawn ring, where temperatures might be more moderate, not too hot, not too cold. But life would have to handle constant winds and a never-changing sky. Think about your daily routine. On Earth, we use the sun to tell time. On a tidally locked world, you can't. Instead, people would probably live by clocks, technology, or natural cycles like wind patterns or ocean tides. Let's zoom out to see how this compares to what we know. Our moon is already tidally locked to Earth, always showing the same face. Many exoplanets we've found close to their stars are probably tidally locked too. Imagine a world orbiting a small red star very close in. It might be tidally locked, but still in the habitable zone, the right distance for liquid water, if the atmosphere can spread the heat enough. Big if, right? Now, what would the sky actually look like on the day side? If the star is a red dwarf, the light might be reddish, turning the whole landscape copper and deep orange. Shadows would be soft and stylized, never really moving. On the night side, the star would never show, but you might see a bright glow from the day side reflecting off high clouds, like a permanent faint aurora spill on the horizon, while constellations remain fixed overhead. Here's a surprising effect. The substellar point, the spot directly under the star, is like the planet's hottest bullseye. Move away from it and the star gets lower in the sky until you reach that eternal sunrise belt all around. So you'd actually choose where to live based on the star's height in the sky. Too close to the center? Boiling. Too far toward night? Freezing. Somewhere in the middle ring might be the sweet spot for cities or ecosystems. Okay, but what about seasons? On a tidally locked planet, seasons depend on how tilted the axis is. With little tilt, almost no seasons at all. With big tilt, the bright spot wobbles up and down over the year, shifting climate bands. This wobble could slowly move the habitable ring, forcing life forms or even civilizations to migrate over centuries, following the best climate as it creeps across the surface. Wild, slow-motion climate change. Now let's flip the question. What if the planet had a very thick atmosphere? Then heat could spread more evenly, softening the extreme contrast between day-side and night-side, making the whole world more livable. But if the atmosphere is thin or stripped away by the star, the result is brutal. Scorched rock on one side, frozen rock on the other, with almost nothing in between. A world divided in two by light and darkness. Here's a mind-bender. If you stood at the exact terminator and walked a few steps toward the star, you'd never see it move. It just gets higher or lower in the sky depending on where you stop. Walking becomes time travel in space. Communication on such a planet could be strange too. Imagine sending signals from dayside to nightside through turbulent atmosphere, or bouncing them off satellites orbiting above both halves, bridging two very different worlds. If intelligent life evolved there, their myths and science would be shaped by this fixed sky. Daysiders might worship the unmoving star. Nightsiders might see only the galaxy. Meeting in the twilight zone would merge both views. So, what have we learned? A tidally locked planet isn't just stuck. It's a world of extremes, giant winds, strange oceans, and perhaps a thin ring where life could cling to eternal dawn. Not dead, just very different. Next time you look at the moon, remember, worlds like this might be common in our galaxy. Some could even host life, staring forever at a frozen sunrise. Want to explore more alien skies and strange worlds with me?